Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is powder flow. The powder flow is important character for any API or granulated semi-finished drug product to get consistent flow and subsequently consistent quality product without variations beyond specification limits. There are few aspects of the powder flow characteristics discussed in this video. Powder flow, angle of repose. Angle of repose is a measure of interparticulate friction or resistance to movement between the particles. Angle of response is one of the important characteristics of the powder. This character evaluates the free-flowing nature of the powder. It is a constant three-dimensional angle relative to the horizontal base. In three-dimensional angle, the tangent of opposite side divided by the adjacent side of the cone will give you angle. If you consider the pile of the powder as a cone, the opposite side is the height of the cone from the bottom to the apex of the cone. Adjacent is the radius of the cone. Select a horizontal surface and take a dry funnel, fix at a convenient height, place a white paper underneath. The funnel used should be smooth and allow free flowing of the material through the funnel without any obstruction. It is also important that the funnel is totally dry. The funnel can be fixed firmly at 2 to 4 centimeters from the base. White paper is to collect the powder in a pile form. The height may be varied if the pile formation is not complete with the height at which the funnel is fixed. Make sure that there are no obvious lumps in the powder or granules for which the angle of repose is measured. This is important. Do not crush the granules or powder, but make sure that there are no obvious lumps in the sample. Using a dry spatula, slowly pour the powder into the funnel to form a pile. Pour the sample till the pile formation is complete and the tip of the pile touches the bottom tip of the funnel. When the pile formation is complete and the height of the pile does not increase anymore, stop pouring the powder further. So at this point of time, stop further pouring of the powder. Measure the height of the pile formed, that is h. In this case, the height is fixed. Carefully circle the pile base with a pencil clearly without disturbing the pile. Measure the diameter at 4 different places on the paper. Calculate the radius r, that is diameter divided by 2, that will be radius. Without disturbing the pile formed, circle out the pile with a pencil carefully. Measure at more points to get accurate diameter of the pile circle. In other method, the base may be fixed and pile formation may be made at convenient height of the funnel. Here in this case, the height of the pile from the bottom to the tip can be measured separately. Angle of repose, that is equal to tan theta, that is your height h divided by radius r. As explained in the previous slide, the tan angle is equal to the height divided by the radius. So theta, the angle of repose, is tan minus h by r. So the angle theta is tan minus 1 of the ratio. The flow property can be explained in this table. If the angle of repose is between 25 and 30, the flow property is excellent, and if it is between 31 and 35, it is good. If it is between 36 and 40, it is fair and does not need any aid. If it is 41 to 45, possible, may hang up. That means there is a slight difficulty here for the flow property. If it is 46 to 55, it is poor and you must agitate or vibrate. And at 56 to 65, it is very poor. More than 66, it is very, very poor. The flow property will be very, very poor if the angle of repose is more than 66 degrees. Compressibility index. Compressibility index predicts the characteristics of powder that may be affected by size, shape, density, surface area, moisture content and cohesiveness of the powder. Compressibility index is another measure for powder flow and its compactness. It is an indicator on the ability of the powder to be compressed. This is also called as Carr index. Since the powder or granules are passed through huge transfer hoppers for making tablets or filling into capsules, there is a possibility of friction because of the entrapped air and uneven flow of the powder. This compressibility index will help to resolve the issue of free flowing of the powder. This is expressed as percentage. The compressibility index is calculated from the untapped and tapped bulk densities or untapped and tapped bulk volumes of powder. Use chapter 616 of USP for more details of the bulk density testing. The formula is 100 multiplied by V0 minus Vf divided by V0, where V0 is untapped volume and Vf is the tapped volume, that is the final volume. So initial untapped volume minus the tapped volume, which will be obviously lower than the untapped volume, divided by the untapped volume, and the resultant ratio when multiplied by 100 will give you the compressibility index. It can be calculated using the untapped and tapped density values also. Mass divided by volume will give the density values. So instead of apparent volume or untapped volume and tapped volume, the density can be calculated. Sample weight divided by the volume occupied by the powder will give the density values. Hausner ratio. This ratio is another way of expressing the powder characteristics. It is calculated as a ratio of V0 and Vf. This is also calculated as ratio of tapped density and untapped density. Hausner ratio is derived factor from the initial volume and the final volume as in bulk density test. This chart explains the flow character against the compressibility index and the Hausner ratio. The more the compressibility index, the poor the flow character, and the more the Hausner ratio, the poor is the flow character. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in comments box for any further support. Thank you.